It's frustrating sometimes. All right, so we're I do. So we are going back to 8-1, day 1, and we left off with 2b here. I want to go ahead and write the answer though. So this f of g of 3, pardon me, equaled 46. Okay, or we could say it was f of g of 3, kind of. All right, so equaled 46. Pardon me, let me go ahead and put that. All right, so now the reason I wanted to put that there is because in C we're doing g of f of 3. So what's different between B and C? The order. This time we're going to do the g first, okay? So this is the g. So instead of having g of x, right, we're going to have g of f of x. Okay, so the f of x is going inside the g of x. Hopefully that helps when we think about it. So we're going to start with our g of x, 2x plus 1. And we're going to put, now we need to put the f of x inside there. So the g of f of x equals 2 times the quantity. What's my f of x?
X squared minus 3.
Okay, x squared minus 3 plus 1. Thank you, ma'am.
Why are you putting in between them?
Okay.
Why, and where did the X go?
Okay, so the x, that's the thing, is that we are saying, like here, we're doing g of x, but we're, okay, but I'm trying to, that's why I showed you this. And so we're replacing that x with the entire f of x formula, expression. So kind of like when we did substitution and elimination. Remember we'd solve for one equation, we'd solve for y, and then we'd replace that whole thing. It's the same process here. So we think, all right, well, I have my g of x equation. So I have this expression part. So I think about that, and then I'm like, okay, now I don't want g of x. I actually want g of f of x. So I put the f of x part in wherever I had an x before. So the x squared minus 3 is my f of x that I put in for the value of x. I substituted it in, kind of like substitution. Does that make sense? Okay, awesome. All right, so now that we've got that set up, we can do the g of f of 3. Okay, so that's this just g of f of 3 this time. So anywhere I see x, what am I going to put in for x? 3. So I've got 2 times the quantity 3 squared minus 3 plus 1. Okay, so 2 times, what's 3 squared? Minus 3? 6, okay. Yeah. I don't know. And what's 2 times 6? 12 plus 1? 13. So g of f of 3 is equal to 13. Where f of g of 3 was equal to 46. So right here we can see, does the commutative property apply to these? No, order matters, okay? F of g is not going to get you the same answer as g of f. Okay, so we have to pay attention to the order. Fantastic. All right, so I want you to try, because you did some. How about we try, well, no, 3 is a little bit different because there is no variable. We're just going to leave it in the simplified form. So here it's nice. In example 2, we had the value. So once we got to this point here, we could go ahead and sub in the number. We didn't have to distribute. We didn't have to do any of that. Well, on that, we have to simplify it. So if we didn't have a value, we would have distributed the 2 and then simplified, combined like terms and all that. So in 3, that's what we're going to do. Okay, we're going to have to simplify it, combine like terms and things because we don't have a value for x. You could totally do that. I have such faith in you. Okay, so if we have f of g of x is what we want, right? Again, it helps me to think, okay, I'm going to start with my f of x, which is x squared minus 3. And then I'm going to insert in there, instead of x, I'm going to put in my g of x in there. So, oh, there's my x. So in place of x, I'm actually going to put my g of x. So the quantity 2, my color was supposed to change to help us see the difference here. So let's try again. So the quantity 2x plus 1, that's my g of x, but it was squared and then minus 3. So this is the same one we did earlier, right? I think, maybe not. Yeah, it is. It's the same. Okay, but the thing is, now I don't have a variable to plug or a value to plug in for my variable. So I have to simplify. So the quantity 2x plus 1 squared is going to be 2x plus 1 times 2x plus 1 minus 3.
Can you just put a square on each one of those? And so 4x squared plus 1.
You cannot.
Binomial.
It's a binomial, so we have to FOIL. Yeah, so it's 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x, and 1 times 1 is, okay, and then minus 3. We're going to combine like terms. So 4x squared. 2x plus 2x is 4x, and then 1 minus 3 is negative 2. And there you have your f of g of x. So equals 4x squared plus 4x minus 2. Now, if like later they gave you some numbers to plug in, you could plug them into that part. However. All right, so let's look at how that compares to the g of f of x. Okay, so again, g of f of x. That's how we're doing this one. So my g of x is 2x plus 1. And then we're going to insert the g of f of x. Okay, and see what that looks like. So it's going to equal 2 times x. What's my x then? Because I want f of x this time. So it's x squared minus 3. That's okay. All right. And then plus 1. Okay, so I need to distribute. 2 times x squared. 2x squared. 2 times negative 3. Minus 6. And then I have plus 1.
Wait.
Yes?
Oh, yeah. Sorry.
You're good.
I was looking at 2 different places.
2x squared minus. How did you go from negative 3 to negative 6?
2 times negative 3 is negative 6. We had to distribute that 2 to every part. Because we have to simplify. Like, because we don't have a value. Before we had like x equals 3, so we could plug the 3 in for x.
Actual full answer.
So since we don't, we need to simplify it as far as we can. And so to simplify it, we have to distribute. Okay, so then our g of f of x equals 2x squared minus 5. Again, commutative property. Are these the same thing? No, not even close, right? The commutative property does not apply to composite functions. Okay. Now, here comes the wonky part, maybe. But you might like it more. Okay, so the same thing is applying, but we have f and f. We have values, like we have a set of values for our f. We have a set of values for our g. Okay, and we want to find each composite function and state its domain. So this is like a road map, okay, that we have to follow, f of g of x. Okay, so here's the thing. If we want, so this one is f of g of x. Well, there are x's. Where are the x's?
Technically, there wasn't f of g of x in any of these other equations.
Yeah, there is, because this is f of g and it has the x beside it.
Okay, well, can you move the page? Well, look at examples up here. We wrote f of g of x, but there's a negative 2. There's no x in that equation. It's just how you write it still.
Okay,
Yeah,
but in this case, they are giving, because they're giving us a set of values, they're giving us the x and the y. So a few things to remember about function notation, right? F of x is the y value, right? And then we always have equals whatever with an x over here. And that's where we put in our x value to get our y value. We have all the parts. But f of x is equivalent to y. And it may help if we rewrite these, but this is, our coordinates are always x comma y, x comma y, x comma y. But these are for the f values. Like I said, it might be more helpful to see it if we write it in a table, but we'll see how it goes first. So when we're doing this, okay, we want to solve the f of g for each, right? It says find each composite function and state its domain. So we want to find f of g, okay, so the function of g, and so we need an x value to put in there. So the g's first x value is 1. So we're going to do f of g of 1.
Well, we don't have an equation to plug that 1 in.
You're right, and we don't need it. I know. That's why I said this is where it's going to get a little wonky. You don't need an equation. This is the same thing, though, remember, as f of g of 1. Okay. So if we say, okay, well, g of 1 is the y value when the x is 1. What's the y value when x is 1 for g? 2. So f of g of 1, okay, is 2. Are we good with that? So we're going to replace the g of 1 with 2 because that's what it is. So now this is the f of 2 equals, well, now we switched and we need to look at the f's. What's the function? What's the y value? What is f of 2? When f is 2, what's the y value? 3.
So this matter which one you start with? Like which number you start with to go down the line?
No, you just need to do all 3 of them, because this is my set. So the next one would be f of g of 2, because 2 is my next x value on the g's. Okay, so then that would give me f of g of 2. Okay, so what is the y value when,
0.
okay, so the y value when the x value is 2, the y value is 0. So then this would be f of 0.
And then you're like, oh, well, the x.
So now I'm at f. When f is, the x value is 0, what's the y? 1. And then we have one more to do.
I don't understand this.
Okay. That's why I said this is, it's like a road map.
So instead of 3, you get a negative 2.
Okay, so we're looking at, so we're going to do f of g. We're looking at we're starting with our g values. G is the inner function. Okay, so we did g when g was, the x value was 1, when the x value was 2, and now we need to solve it when the x value is 3. Okay.
So all of these were ordered pairs. Why, when we're running it through, we're getting like sets of 3?
We're not. Well, I'll show you how the final answer comes out in the wash. Those are just your intermediate steps like other things. Okay, so we're doing, so this is the x value that we have left. So then we can rewrite it in this f of g of x, but our x value is 3 here. So when our x value is 3, because again, okay, if we have g of x equals, I don't know, 2x, whatever, okay, plus 7. This is the same thing as saying y equals 2x plus 7. So this f of g, or f of g of 3, so our g, when the x is 3 in the function for g, what is the g of 3? Or what's the y value? So Ethan, when x is 3, what's the y value? Okay, it is -2. So we are saying, oh, well, this is actually -2, so it's f of -2. So, but now we're saying, oh, I need to look at the f function. When is the x value -2? Okay, right here. Okay, so what is the f, what is the y when the x is -2? -1. So this is just the work, okay, to solve it. But like, so our final answer, it is, because f of g, okay, our f of g that we were talking about equals the set, and we write them as ordered pairs. 1, 3. And the next pair is 2, 1. And the last pair is 3 and -1. So like yesterday when we were doing this, and I talked about there are times whenever, like, maybe if you have a business or you're selling something and like you're trying to link all these things together, like you have to have all these different pieces of information. If I sell, oh, I can't use -2, but if I sell 2 pieces of equipment, this is how much money I make. Or how much like sales I'm getting, right? But then I also know that if I do that and that links to the actual income that I'm making, or how much, maybe the rate I have to pay people for selling those, like, you know, to make those, to sell them. So I can put all these equations together and get just one simple one instead. Or just get out the key pieces of information that I need. And so we can create these roadmaps to do that, to pick the part of the equation that we need when we need it to solve for us. Okay, so the last part of it says to tell its domain. Okay, those are the x values, yes. So once we have done this, what are the x values? What is the domain? I'm going to write it over here because I don't have room. 1, 2, and 3. You got it. 1, 2, and 3 is the domain of the f of g there.
Well, honestly, it won't always work out like this, will it?
Where it's 1, 2, and 3.
Well, here, so of the g that we're finding of, it goes from left to right of the x values, and of the f, it goes from the right to the left of. No, it doesn't. Wait a minute, where did I get this?
I don't know. But it will not always work out. Sometimes the next one we're going to do, we won't even have 3 values because it doesn't link to the next one.
So on the bottom one, they line up. It goes from left to right on the bottom, and then left to the right on the right side.
Well,
So
these are our...
X values of the G line up with the X values of our final thing, and the Y values of our F line up with the Y values there. Just flip-flop.
Correct.
Is that always going to happen?
Yeah, it'll always be one of them because that's going to be our thing. But they don't always...
They don't always work in that order to where all of the X's are lined up in order, and all
Well-
the Y's are reverse order. So then I'm just saying, like, because then if we had seen this, we could skip all of the work and just write it out like that. Put the Y values of our first one backwards, and then, see what I'm saying?
I do see what you're saying now.
But it's
That
not,
they
probably
combine.
won't
It
always work out like that.
will not always work out like that. No.
Okay,
Yeah, it won't always work. And so I'm going to show you why it doesn't work in the next one. Okay, so let's try the last one there. And we're going to do something different. I went ahead and cleaned it all up. So maybe if I did like my F values up here, and we have -2, I'm going to go like this, -1, if I could write. Right, -2, -1, and then we have 0, 1, and then we have 2, 3. And these are my F values. Then my G values over here are 1, 2, 2, 0, and 3, -2. We'll see if this will help us a little bit in the next step. Okay, so the next one is G of f of x. Okay, or so we're going to do G of f of what value? What's my first x for the f? Okay, so my f, here we go, is -2. Okay, which means, and maybe if it's an equal sign, maybe if I drew the arrow would help. So I want to find the G of f of -2. Okay, so then we need to think, all right, what is the y value when the x is -2 and my f function? So we come here, here's my f function, my x is -2, what's the y value? What's the f of -2? Ethan? -1. Okay, so now I'm going to replace all of this with its actual value, which is -1. So I want the G of -1 next. Okay, so this time I need to come look at my G functions. Where is the x value -1? It's not, right? Like I don't have a -1 in there. So this is not defined. So this goes back to it doesn't always work out like that, Josh. Okay, so next we're going to do the G of f for our next x value in the function of the f function, so 0. So I can rewrite that as G of f of 0. So when in my f function, when my x is 0, what is the f of x? Brandon? 1. Okay, so I'm going to replace this with, I'm replacing that whole chunk with 1. So it's G of 1. Okay, so now, because I'm looking at my G function, when x is 1, I go to my G function, hey, x is 1. What is G of x when x is 1? Ethan? 2. So this equals 2. So if I was making my like final answer, this would be my first ordered pair, right? I had 0 is my x, my starting out x, and 2 is my final pair. All right, let's do the last one. So I need to do g of f of, what's my last function? 2. All right, which I can rewrite as g of f of x. Okay, again, so I'm going to look at my f function, and when my x value is, I wrote x instead of 2. When my x value is 2. So in my f function, when my x is 2, what's my f of x? 3. So I'm going to replace this with the number 3. So g of 3. Okay, Brandon, what is my g of 3? -2. Like, that was quick. You were ready. So my color didn't change, doggone. Okay, so there was my x was 3, and so my g of 3 is -2. Which, Brandon, what's that make this ordered pair? 2, -2. Rockstar. And that's it. Okay. What's my domain then here? Did you say 0, 2? Okay, so my domain is 0, 2. Awesome.